We now determine dy by dx given that y equals a sine x plus b cos x divided by a sine x minus b cos x. So we can find the dy by dx using this quotient rule. That is, the rule says if y equals f of x over gx over g of x, then dy by dx is given by this quotient. That is g of x times f prime of x. This f prime of x is the derivative of f of x with respect to x minus f of x times g prime of x. And g prime of x is the derivative of g of x with respect to x. And this is all over g of x quantity squared. So we are going to utilize this formula to find dy by dx. So I write down dy by dx. I can consider the numerator expression as f of x, and the denominator expression I can consider this as g of x. So when we use the formula, we first put the g of x multiplied with the derivative of f of x. So I'm going to write the expression for g of x, which is a sine x minus b cosine x times we have to write the derivative of f of x. So I'm going to write the derivative of f of x. So here we have to find the derivative of a sine x, which is a cosine x. And then the next term in f of x is b cosine x. So when you find its derivative, we will get negative b sine x because the derivative of cosine x is sine x. So we can rewrite this as negative of b cosine x. Okay, here I have written that. And then if you look at the formula, we have to put this negative, and then the product is f of x times g prime of x. So I put this negative, and then I have to put the f of x as it is. That is a sine x plus b cosine x times derivative of the g of x. So let me put the derivative of g of x. We have a sine x, its derivative is a cosine x minus the derivative of b cosine x is negative b. The derivative of cosine x is negative sine x. So it is basically negative times negative is positive. So we can simply write this as positive b sine x. This is positive b sine x. Okay, which I have written it here, and this should be all over the g of x quantity square. So I have to find the square of g of x. So let me write sin x, that is a sin x minus b cosine x. This is the expression for g of x. We have to take its quantity square. So it's basically we have to simplify the numerator and give it in a very simplified form. So let's write dy by dx. So let's FOIL this out. We have two terms in the first expression, and we also have two terms in the second expression. So I'm going to FOIL this out. So I consider the term by term. The first term here is a sine x. The first term here is a cosine x. So if we multiply these two, we will get a squared sine x cosine x. Now let me consider the first term as plus this last term in the second expression. That is, when you multiply these two together, you will get negative AB, and then sin x times sin x is sine squared x. Now let me consider the second term in the first expression, that is negative b cosine x, and then I multiply with a cosine x. So this will be negative AB cosine x times cosine x is cosine squared x. Now I consider this negative b cosine x, and then this negative b sine x, that is the second term in the second expression. So negative times negative is positive. So we will get positive b squared, and then cosine x sine x, or we can rewrite this as sine x and cosine x. So we have completed foiling the first two terms. Now let's foil the second two terms. So we have a negative. So all the terms that we foil this out, they are going to be negative because this is plus, and here also in the second expression also we have positive quantities. So every term that I'm going to foil out, I'm going to write down as a negative term. So first, let's consider this a sin x with a cosine x. We multiply them together. So when you do that, we will get negative a squared because since we have a negative in front, we will get negative a squared and then sine x, cosine x. Now let's consider this a sin x and multiply with this b sin x. So it will be ab sine squared x, but since we have a negative, it is negative ab sine squared x. Now let's consider this b cosine x multiply with a cosine x. So it's going to be ab cosine squared x. But we have to put this as negative. So it is negative ab cosine squared x. Now let's multiply b cosine x with this b sine x. So it will be positive b squared sine x cos x. But since because of this negative, we put this as negative b squared sine x and cos x, and this should be all over a sin x minus b cosine x quantity square. Now let's simplify the terms in the numerator. We will have some like terms. We can cancel them. This is negative a squared sin x and this is positive a squared sin x. So these two terms are getting cancelled. Also, we see that this is positive b squared sin x cos x and this is negative b squared sin x cos x. These two terms are getting cancelled. And so we are left out with negative ab sine squared x and negative ab cos squared x, negative ab sine squared x, and negative ab cos squared x. So let's combine these two terms. When we combine the like term sine squared x, we will get negative 2ab sine squared x. And when we combine the cos squared x, we will get negative 2ab cos squared x. And this is all over the denominator a sine x minus b cosine x. This is quantity square. We can simplify the numerator by factoring out negative 2ab. So I factor negative 2ab, and when I do that, I get sine squared x in the first term plus cosine squared x in the second term. And this is all over by the same denominator, that is a sine x minus b cosine x. This is quantity square. And now we use the Pythagorean identity, that is sine squared x plus cosine squared x, this equal to 1. Or in fact, we can also say this x can be replaced by theta, that is sine squared theta plus cos squared theta equals 1. So basically this expression, that is sine squared x plus cos squared x, this reduces to 1. So we will get negative 2ab times 1, which is negative 2ab, and this is all over the denominator a sine x minus b cosine x quantity square. So this is the simplified form of the derivative expression, that is dy by dx equals this expression.